I want to talk about multiplying matrices. And in order to do that, let's start with a row matrix, which we'll call R. And it will just be R sub 1, R sub 2, and so on until you get R to R sub n. So I'm calling it a row matrix because it's a single row and an n number of columns. And then I'm going to look at matrix C, which will be a column matrix. And we'll call the entries C1, C2, and so on until you get down to C sub n. So the product of R times C is defined to be this. R1, C1, in other words, the product of those two entries, plus the product of the next two entries, plus, keep going until you get to the end of the row and column, and you're multiplying R sub n by C sub n. And you would do the arithmetic and come up with a single number. So let's see that play out using a couple of matrices with numbers. So I'll let the matrix R equal 1, negative 5, 4. And we'll let the matrix C equal 9, 3, negative 2. So if we're going to do that calculation, R times C, we'll have 1 times 9 plus negative 5 times 3 plus 4 times negative 2. And now we just do the arithmetic and we have 9 minus 15 minus 8. And what is that, negative 14? And so we have a single number that is the product of this row matrix and that column matrix. But now let's talk about multiplying matrices in general. Well, let me talk about it with larger matrices. I'm not going to talk about it generally. I'm going to talk about it with a 2 by 2 and 2 by 3 matrix, just not a row and a column. So here we go. I'm going to let the A matrix equal negative 3, 4, 11, and negative 1. I'll let the B matrix equal 6, 1, 0, 5. And I'm going to come up with a third matrix. We'll call it matrix C. And it will be 3, 2, negative 1, 5, 6, 3. So those will be the matrices that we'll use for the next few problems when we're multiplying. So let's first find the product of A times B. So we have negative 3, 4, 11, negative 1 that we're multiplying by 6, 1, 0, 5. Now we're going to use the idea of multiplying a row by a column to figure out each entry in the resulting product of these two matrices. It is not as we did with addition of matrices where you could just look at corresponding entries. That is not the way multiplication works. So here's what we're going to do. We're going to look at this row and this column, and we'll put them together the same way we did as in the product of that previous row and column. So the result will look like this. Negative 3 times 6 plus 4 times 0. We will have a single entry, and that will go right here in our resulting matrix. So it's this row, first column will be put in the first row, first column in the result. So it's negative 3 times 6 plus 4 times 0. That's just my first entry in the result. So now I move on to the next column. Let me make this be my 0 here. And now I'm moving right here, and I'm using the first row, second column, so the result will go in the first row, second column. So I have -3 times 1 plus 4 times 5. And as you practice this, you'll find that you'll be able to do the arithmetic in your head a little bit more. I just want you to see the details. That takes care of this row. I multiplied it, I used each of the columns there. So now we're going to move on to the second row and repeat the process with this second row. So now I'm using the second row, first column, and here we go. 11 times 6 plus -1 times 0. And then I move to my next column. So now here I am, looking at row 1, column 2, row 2, column 2. So my result will be in row 2, column 2. Here's where it's going. So it's 11 times 1 plus -1 times 5. And now we have some arithmetic to do for that result. So we have -18 plus 0. We have -3 plus 20. We have 66 plus 0. And we have 11 minus 5. And there's our result of our product of A times B. So make a note, -18, 17, 66, and 6 is our matrix that is their product. Let's find the result when we have B times A. Notice that was A times B. Let's do the same process looking at B times A. So B times A. Now this matrix is first 6, 1, 0, 5, and we're multiplying it by -3, 4, 11, -1. So here we go. We're looking at first row, first column. 6 times -3, I'm just going to write that as -18. 6 times -3 plus 1 times 11. Let's move on to the next column. So still on row 1, now we're on column 2 over here. 6 times 4 plus 1 times -1. Let's move down to the second row, first column. 0 times -3 plus, so here we are, we're working here. 0 times -3 and 5 times 11. And last we have row 2, column 2, 4 times 0 plus 5 times -1. And when we do the arithmetic, we get -7, 23, 55, and -5. And you'll notice that that is not the same result that we got when we multiplied A times B. So we can see that multiplication is not commutative. Different than when you're working with arithmetic. But when we're multiplying matrices, the order in which you write the matrices down matters. Let's do another one. Let's look at A times C. We have -3, 4, 11, -1. And we're going to multiply it by 3, 2, -1, 5, 6, 3. And let's start with our first row right here. and we'll move through the columns of matrix C. So here we go. Let me put my brackets up here. We have -3 times 3, so we have -9 plus 20. We move to our next column. Stay with the first row here. We're in the second column. -6 plus 24. Third column. A +3 plus 12. Easy to make a little arithmetic mistake on this, so you got to keep your brain on high power. That takes care of our first row. Let's move down to the next row. Let me not do that with my finger here, make it a little bit nicer. Let's move down to the second row right here. So we're moving across the matrix C, starting with column 1. 11 times 3 plus -1 times 5. So 33 minus 5. Next entry. 22 plus -6. Last entry. -11 plus -3. So our result is 11, 18, 15, 28, 16, and -14. And we have the product of A times C. And let me point this out. Unlike addition of matrices, where the dimension of the matrices need to be the same number of rows and same number of columns, that is not the case here. Notice we multiplied this 2 by 2 matrix by this 2 by 3 matrix, and we were able to do that product. Let's look at what happens if we try to multiply C times A. So let's do that. So we're looking at C times A. We already have mentioned that it's not commutative. So let's write 3 to -1, 5, 6, 3. And we're going to multiply that by A, which is -3, 4, 11 at -1. And here we would go. We would use this row and this column. So let's see what we would have. We would have -9 plus 22 and you'll notice that we're shy an entry here. So in fact, we can't even do the multiplication. So we say that C times A is undefined. And notice what we had. We had a 2 by 3 matrix that we were multiplying by a 2 by 2, or trying to multiply by a 2 by 2. But we needed the number of columns to match the number of rows so that we would have those entries corresponding. We would need one more row down here in order for us to be able to do that multiplication. We would need 3 rows here. In other words, when you're looking at a product of matrices, I'm looking at these two right here. The number of columns in the first matrix and the number of rows in the second matrix must match if the matrices are going to be able to be multiplied together. Otherwise, their product is undefined, as they were in this case. So let's do another problem. Let's start with some new matrices. We'll just erase these. I haven't even erased the title, so I have a little more space. So let's have a 2 by 3 matrix. We'll call it D. It will be 4, 1, -1, 6, negative 2, negative 3. That will be matrix D. We'll make a matrix E be a, that was a 2 by 3. This is going to be a 3 by 2. 5, negative 5, 1, 4, 3, 10. And one last matrix, let's make it matrix F, and it will be 2, 9, negative 1, negative 10. Sure. There we go. So here are the matrices we're going to use, and let's again do some multiplication. So let's start with DE. So we're going to take the product of 4, 1, negative 1, 6, negative 2, negative 3, and we're going to multiply it by 5, negative 5, 1, 4, 3, 10. Notice this is a 2 by 3 matrix here. This is a 3 by 2 matrix here. These are a match. So we know we can take their product. Here's something else that we will figure out, or that you will see. The resulting matrix will have this many rows and this many columns. So if I'm multiplying a 2 by 3 by a 3 by 2, the result will be 2 by 2. So I'm expecting a 2 by 2 over here. So let's do the product. We have 5 times 4, 20, plus 1 times 1, plus 3 times negative 1. There's our first entry. First row, first column. Maybe I'll even point out, we're doing first row, and then I'm just moving across the columns. First row, second column, so our entry will go right here. We'll have negative 20 plus 4, negative 20. I'm going to need a little space, more space, plus 4. So I'm looking at this row, this column, negative 20 plus 4 minus 10. And that takes care of our first row. Let's move down to the second row. Just going to erase that and write it back in a little bit neater. So we have 4, 1, negative 1 here. So now we're using the second row, and we're going to go through our columns. So second row, first column. And notice we'll have a 30 minus 2 minus 9. 30 minus 2 minus 9. First row, second column, our entry is going right here. Negative 30 minus 8 minus 30. So negative 30 minus 8 minus 30. So if we do the arithmetic, we'll have 18. What do we have here? Negative 26. 19. And negative 68. So notice again, our 2 by 3 multiplied by a 3 by 2 resulted in a 2 by 2 matrix right there. We already know commuting them doesn't give the same result, that multiplication is not commutative with respect to matrices. So let's multiply these two matrices in the other order if it's possible. Let's try. So we'll have the E matrix first. It's 5, negative 5, 1, 4, 3, 10. And we're multiplying it by 4, 1, negative 1, 6, negative 2, negative 3. And here we go. First, let's confirm that it's doable. We have a 3 by 2 multiplied by a 2 by 3. Notice these are a match. So the expectation is we can multiply them. And notice we will have a 3 by 3 as our result. We're going to have a 3 by 3. I'm going to make that kind of big. So even the dimension of the product will be different, or can be different if you commute the matrices. So here we go. We're going to use the first row, and we're going to move through the columns. And let's see if we can just do the arithmetic and write down the entries. So here we go. We have a 20 minus 30. So we're multiplying and multiplying, and we'll add those together. So 20 and negative 30. Move to the next column. 5 and 10. Negative 5 and 15. And that takes care of the first row. So now we're going down to the second row. So here we are, we're using this row here. And again, we're going to move through the columns in the second matrix. So 4 plus 24. Next column. 1 plus negative 8. Negative 1 plus negative 12. And last, we're down to our third row, right here. And again, we'll move through the columns. 12 plus 60. 3 plus negative 20. Negative 3 plus negative 30. And we have the product of this 3 by 2 multiplied by this 2 by 3. Let's do another problem. Suppose that we were going to look for d squared. Well, that just means we would multiply d by itself, 4, 1, negative 1, 6, negative 2, negative 3, by 4, 1, negative 1, 6, negative 2, negative 3. But notice that means we're multiplying a 2 by 3 by a 2 by 3. And these do not match. So this is undefined. And notice if we were going to square a matrix, the number of columns would need to match the number of rows, as in the case of this matrix over here. In other words, it would need to be a square matrix. That's what we call a matrix that has the same number of rows and columns. So we can't square D, but we could square F. It is just 2, 9, negative 1, negative 10. Multiplied by 2, 9, negative 1, negative 10. So you'll notice you can only square a square matrix, right? We need the number of columns to match the number of rows. So here we go. Let's practice again. Right? And you could pause this video and try it on your own and see if we get the same results. So here we go. Row here, column here. So it's 4 plus negative 9. Row 1, column 2, 18 minus 90. What's that, negative 72? Now we're on row 2. So I'm in row 2, column 1, negative 2, positive 10. And negative 9 plus 100. And we have the product. I'd like to look at one more thing before we stop with this multiplying of matrices. Suppose I had this matrix equation. 14, 2, 9, 7. And I were was multiplying it by the matrix xy, and I set it equal to negative 1622. So I have this matrix equation. Let's see what it looks like if we multiply these two matrices together. Notice it's doable. This is a 2 by 2 multiplied by a 2 by 1. Those are a match, and our result is going to be 2 by 1. So first row, first column, so we have 14 times x plus 2y. 14x plus 2y. That's our first entry. And now that takes care of our first row. There was only one column. So now we go down to our second row. 9 times x plus 7y. 9 times x plus 7y. So there's our product of these two matrices, and it equals negative 1622. Now it turns out that matrices are only equal if their corresponding entries are equal. So this is equivalent to 14x plus 2y equaling negative 16, and 9x plus 7y equaling positive 22. So we have this matrix equation that we can see is equivalent to this system, this linear system. And notice right here, this matrix represents the coefficients of x and y. This matrix represented the constants. Well, it turns out that we can do this process in reverse. We could start with a system that looks like this. Let's write a 3 by 3 linear system. 9x minus y plus 4z equals 12. X plus 3y plus 7z equals 2. And x minus 6y plus 20z equals 0. So the corresponding matrix equation would look like this. We would write a matrix that contains the coefficients of the variables on the left side. So we would have 9, negative 1, 4, 1, 3, 7, 1, negative 6, 20. Now we would have a matrix, a column matrix that represents the variables. In the previous one it was x and y. This one we need x and y and z. And you could confirm that when you multiply this matrix by this column matrix, you end up with the quantities here on the left. But we want that product to equal this constant matrix, 12 to 0. Now the ability to take a linear system and rewrite it as a matrix equation will lead us to another way of solving systems, but that's going to be a topic of another video. For now, go practice multiplying matrices together.